Architect Meera Milan Ajit. She is currently working as a senior architect at L&T Construction, Buildings and Factories. She has worked for various commercial and institutional projects for the Engineering Design Research Center, ranging from shopping malls, IT parks to metro rails. She has attended many national conferences and seminars. She has also worked as a freelancer in Chennai for various projects.
Welcome to UGC lecture series in architecture. I'll be taking you through earthquake resistant architecture, that is AR 6008, lecture 10. When in the previous lectures we saw what are the various criterions that had to be considered to be prepared, be aware, and be ready of the earthquake from the architecture's perspective. We understood what is an earthquake, how and when does an earthquake strike, what are the aftermaths of the earthquake, what are the various terms and terminologies that surrounds the earthquake. We understood the various construction materials and construction technologies that had to be followed and adapted in order for earthquake resistant construction of earthen buildings, wooden buildings and RC structures. We also understood what are the beams and the columns and how are the beams and the columns working how does a beam and the column work together in order to make a building, an RC building, earthquake resistant. We understood the importance of steel and steel and concrete in earthquake resistant architecture. Moving on to this particular unit, we would now be seeing a broader perspective of the earthquake resistant architecture. We are now from the technical building oriented study, we are now moving to a broader area where we will understand the urban planning introduction from the perspective of the earthquake resistant architecture. We would be seeing vulnerability of existing buildings. We would see the repair, restoration and strengthening process of buildings. We would see the various materials that used for the repair of buildings. Moving on to the first and foremost part of this particular lecture, that is the urban planning and design. So, why and when do we usually do urban planning? Urban planning is a very different specialization. It's not something that can be minimized and put into one subject. So, why are we still learning urban planning in this particular lecture? It is because urban planning kind of helps you. Every time you learn urban planning, you actually learn about what are the various factors that had to be planned in order to make a city, what are the various planning considerations when you do an urban area. But this particular lecture, we would be seeing more of the urban planning from a very different perspective, that is the seismic perspective, like what are the various factors that has to be considered while creating an urban area, a building for an urban area, by keeping it earthquake resistant. So, that is a major thing that we will consider here. So, urban planning is a technical and political process concerned with the development and use of land, planning permission, protection and use of the environment, public welfare and the design of the urban environment, including air, water and the infrastructure passing into and out of the urban areas, such as transportation, communication and distribution networks. So, first and foremost thing that we will be seeing right now is the vulnerability of existing buildings. So, if you can see in the picture, every town will have one set of buildings that are already existing in it. So, what happens when an earthquake strike in that particular area? Would those buildings be able to stay intact and not be vulnerable to earthquake, or would they be vulnerable and would they actually come down and get demolished or fall down as a part of the earthquake? So, if you can see, this city before earthquake looked like this, and once the earthquake struck, it looked like that. There are some building that still stays, there are some building that proved to be earthquake resistant, there are many buildings that actually gave up and that fell down. So, you can see out of all the buildings that fell down, only one or two are still existed, only one or two are still staying, others all fell down. So, talking about the vulnerability of existing buildings, the problems of repairs, restoration and seismic strengthening of buildings are briefly stated. So, before the occurrence of the probable earthquake, the required strengthening of seismically weak buildings is to be determined by survey and analysis of the structures. 2. Just after a damaging earthquake, temporary supports and emergency repairs has to be carried so that precautiously standing buildings may not collapse during aftershocks, and the less damaged ones could be quickly brought back into use. So, the real repair and strengthening problems are faced at the stage after the earthquake, when the things start settling down. At this stage, distinction has been made in the type of action required, that is repairs, restoration and strengthening, since the cost, time and skill required in the three may be quite different. The decision as to whether a given building needs to be strengthened and to what degree must be based on calculations that show if the levels of safety demanded by preset codes and recommendations are met. Difficulties in establishing actual strength arise from the considerable uncertainties related with material properties and with the amount of strength deterioration due to age or to damage suffered from the previous earthquakes. So, the method of repair and strengthening would naturally depend very largely on the structural scheme and the materials used for the construction of the building in the first instant, the technology that is feasible to adopt quickly, and on the amount of funds that can be assigned to that task, usually very limited. Some methods like bandages, wire mesh, epoxy injection, etc. have already been tried and applied in various countries for repairing as well as strengthening earthquake damaged buildings. So, moving on to the next major topic, that is repair, restoration and strengthening concepts. So, the underlying concepts in the three operations are: for the repairs, the main purpose of repairs is to bring back the architectural shape of the building so that all services start working and the functioning of the building is resumed quickly. So, repair does not pretend to improve the structural strength of the building and can be very deceptive for meeting the strength requirements of the next earthquake. So, what happens when there is a building and a building fails during the earthquake? It falls, yet it's half of it is still standing or most of it is still standing, and if the damage caused by that earthquake on the building is very limited, then that can be repaired in order to be used again immediately. So, once an earthquake strikes a place, there might be many reasons why a building needs to be recovered, because there are many people that will be homeless, there will be many people who will immediately need their house back into full form. So, that is when they do repairs. Usually the fund effect allowed for the repair works after the earthquake is very limited. So, what does repair do? They usually bring back the building into full working form, wherein it will have all the services and all the functionalities of the building will be that would be working again. But structurally being stable or not is not unsure of when the repair works are being carried out, because basic structural stability can't be promised. So, the actions will include patching up of defects such as cracks and fall of plaster, repairing doors, windows, replacement of glass panes, checking and repairing electrical wiring, checking and repairing gas pipes, water pipes and plumbing services, rebuilding non-structural walls, smoke chimneys, boundary walls, etc. So, if you can see in the picture, you can see how one part of the building had fallen down, and after repairing it, it was brought back into a functioning building. So, the structural stability of this building is unsure of, like will that withstand another earthquake is not unsure of. But the patching works and the patching work of repairs like cracks and plaster cracks, and the doors and windows replacement, and the electrical, the gas line checking and plumbing checking and the water pipe checking, all that is run and that is repaired. So, the action will include replastering of walls as required, rearranging distributed roofing tiles, relaying cracked flooring at ground level, and redecoration, whitewashing, painting, etc. So, the architectural repairs as stated do not restore the original structural strength of the cracked walls or columns, as I said before, and may sometimes be very elusive. Since the redecorations buildings will hide all the weaknesses and the building will suffer even more severe damage if shaken again by an equal shock, since the original energy absorbing capacity will not be available. So, once a building is hit by an earthquake and all the repair works are done, it looks really finished, and from outside it gives you a perspective as like it would look really complete and neat. So, it kind of hides the camouflages the original structural deficiency of that particular building. So, once again if the aftershock is as strong as the original earthquake or another earthquake strikes the same area, the building will be even more prone to that earthquake than how it was before the first earthquake strike did, because repair does not give it structural stability, but because it will already be hit by the earthquake, structurally it will be even less stronger than what it was before the first earthquake strike. So, the damage will be way more. Talking about restoration, it is a restitution of the strength the building had before the damage occurred. This type of action must be undertaken when there is evidence that the structural damage can be attributed to exceptional phenomena that are not likely to happen again and again, and that the original strength provides an adequate level of safety. The main purpose of restoration is to carry out structural repairs to load-bearing element. It may involve cutting portions of the elements and rebuilding them, or simply adding more structural material so that the original strength is more or less restored. The process may involve inserting temporary support, underpinning, etc. So, maybe once an earthquake strikes a particular building and the building is the architecture finishes of the building is completely gone, whereas structurally it seems a little stronger than another building, then a structural restoration is made so that the building will start functioning structurally as good as it would have before the earthquake strike, and structurally it will be made into a stable structure again. So, this particular process is called restoration. So, this can be done with multiple ways, by adding columns or adding elements or adding structural pins. Multiple ways are there in order to do restoration. So, if you can see in this particular picture, this particular church had fallen off during the earthquake, and a restoration work is being carried out, a structural restoration work is being carried out, which will make the church look as architecturally complete as well as structurally very stable. So, some of the approaches for the restoration are the removal of portions of cracked masonry walls and piles and rebuilding them in richer mortar. Use of non-shrinking mortar will be preferable. Addition of reinforcing mesh on both faces of the cracked wall, holding it to the wall through spikes or bolt and then covering it suitably. Several alternatives have been used. Injecting epoxy-like material which is strong in tension into the cracks in walls, columns, beams, etc. So, these kind of restoration works are even carried out in multiple other areas, especially by Archaeological Survey of India when there are historical buildings that are being restored, or by other restoration processes for any other structural building. So, those kind of restoration processes are used for the earthquake affected buildings in order to bring it back to structural stability. So, the seismic behavior of old existing building is affected by their original structural inadequacies, material degradation due to time, and alterations carried out during use over the years, such as making new openings, addition of new parts including dissymmetry in plan, elevation, etc. So, the possibility of substituting them with new earthquake resistant building is generally neglected due to historic, artistic and social economic reasons. So, the complete replacement of the building in a given area will also lead to the destroying a number of social and human links. Therefore, seismic strengthening of existing damaged or undamaged buildings can be definite requirements of the same areas. So, strengthening is an improvement over the original strength when the evaluation of the building indicates that the strength available before the damage was insufficient and restoration alone will not be adequate in future quakes. So, what happened once? So, there are some buildings which we repair, there are some buildings that we restore, there are some buildings that we strengthened. So, the difference between the three is very important to understand. In repairing, we only repair the architecture finishes of the building just to make it more livable. We bring back the services into functioning, we bring back the architecture finishes into proper, that makes it look really stable, but structurally it will be even more brittle or even more less stronger than how it was before the first earthquake struck it. In restoration, what do? Is we realize that the first structural stability of the building is good enough before the earthquake struck it, and it still can be repaired to be a structurally strong building. So, what do? What we do is we add structural stability and structural members to that particular building and make it look more, make it structurally more strong or as strong as it was before the earthquake affected it, because we are kind of restoring the structural quality that the building possessed before the earthquake hit it. And strengthening of the existing building is when we realize that the amount of strength that the building possessed before the earthquake hit it is not completely sufficient. So, it is important to re-strengthen it and increase the strength of that particular building and structural strength of that particular building and make it more suitable for the future quakes, if any. So, if you can see in this particular picture, you can see that many structural elements are added and the structural stability is being improved in the particular building. So, the extent of the modifications can be determined by the general principles and the design methods stated in the other discussions that we had before in the other lectures, and should not be limited to increasing the strength of the members that have been damaged, but should consider the overall behavior of the structure. So, basically, in restoration, we consider each and every element of the particular building that was structurally damaged and we restore it. And in here, we consider the overall building and the structural performance of the overall building, and we work out the structure of that particular building based on the overall building, and we redo the structures. So, commonly strengthening procedures should aim at one or more of the following objectives, that is, increase the lateral strength in one or both directions by reinforcement or by increasing wall areas or the number of walls and columns, giving unity to the structure by providing a proper connection between its resisting elements in such a way that the inertia forces generated by the vibration of the building can be transmitted to the members that have the ability to resist them. Typical important aspects are the connections between the roof or the floors and walls, between intersecting walls and between the walls and foundations. Eliminating features that are sources of weakness or that produce concentrations of stresses in some members, asymmetrical plan distribution of resisting members, abrupt changes of stiffness from one floor to another floor, concentration of large masses, large openings in the wall without a proper peripheral reinforcement are examples of defects of this kind. Avoiding possibility of brittle models of failure by proper reinforcement and connecting of resisting members. So, since its cost may go as high as 50 to 60% of the cost of the rebuilding, the justification of such strengthening must be fully considered. So, basically, than going for a rebuilding of a particular site, because there are some human links and there are some reasons why the buildings can't be restored, we are actually investing 60% of the total money of a restoring of a building to actually going to strengthening the building. So, that's the reason why each and every element, the structural element that particular building should be completely analyzed, completely understood, and then seen. The building should be seen as a whole structural element, and then the strengthening of the structure should be done so that it can withstand the quake. So, what repair materials? So, the most common materials for damage repair works of various types of cement are cement and steel. So, in many situations, non-shrinking cement or an admixture like aluminium powder in the ordinary Portland cement will be admissible. Steel may be required in many forms like balls, like rods, like angles, like channels, like expanded metal and welded wire fabric. Wood and bamboo are the most common material for providing temporary supports and scaffolding etc. and will be required in the form of rounds, sleepers, planks etc. So, shotcrete is the first repair method that we use. Shotcrete is a method of applying a combination of sand and Portland cement with mixed pneumatically and conveyed in a dry state to the nozzle of a pressure gun, where water is mixed and hydration takes place just prior to expulsion. The material bonds perfectly to properly prepared surfaces of masonry and steel. In versatility of application to curved or irregular surfaces, its strength after application and good physical characteristics make for an ideal means to achieve added structural capability in walls and other elements. There are some minor restrictions of clearance, thickness, direction of applications, etc. Next is epoxy resins. Epoxy resins are excellent binding agents with high tensile strength. These are there are chemical preparations, the compositions of which can be changed as per requirements. The epoxy components are mixed just prior to the application. The product is low viscosity, can be injected in small cracks too. So, the higher viscosity epoxy resin can be used for surface coating or filling larger cracks or holes. The epoxy mixture strength is dependent upon the temperature of curing, lower strength of the highest temperature and method of application. For larger void spaces, it is possible to combine epoxy resins of either low viscosity or higher viscosity with sand aggregate to form epoxy mortar. So, epoxy mortar mixture has given higher compressive strength, higher tensile strength and lower modulus of elasticity than Portland cement concrete. Thus, the mortar is not a stiff material for replacing reinforced concrete. It is also reported that epoxy is combustible material, therefore, it is not used alone. So, this is the most common repair material that we use, the epoxy one. The sand aggregate mixed to form the epoxy mortar provides a heat sink for heat generated and it provides increased modulus of elasticity too. The next is the gypsum cement mortar. It has got rather limited use of structural application. It has lowest strength of failure among these three materials. So, first one is a quick setting cement mortar. So, this material is patented and was originally developed for the use as a repair material for reinforced concrete floors adjacent to steel blast furnaces. It is a non-hydrous magnesium phosphate cement with two components, a liquid and a dry, which can be mixed in a manner similar to Portland cement concrete. Next is the mechanical anchors. So, mechanical type of anchors employ wedging actions to provide anchorage. Some of the anchors provide both shear and tension resistance. Such anchors are manufactured to give sufficient strength. Alternatively, chemical anchors bonded in drill holes, polymer adhesives can be used. So, basically, we learned about like four major repair materials for the buildings. So, as I said, when we do repair of a building, what we basically see is we kind of find out small architectural failures of that particular building and service failures of that particular building and kind of brings it back into working condition. So, what we do is we do not add new materials to it, we just add adhesive to it or add more material to the existing failure so that it would actually come back to working condition. So, these kind of repair works are done only in the buildings wherein the damage is very limited. So, that is why the first material, that is shotcrete, is a combination of sand and Portland cement, and that so this is converted in dry state and it is added to the nozzle of a pressure gun, and then the water is mixed and that is where the hydration takes place and then we expel it. So, the best part about this particular method is that it bonds perfectly to properly prepared surfaces and like masonry and steel, and then make it look new. So, basically in the applications of curved and irregular surfaces, it shows high strength after applications of and also good physical characteristics. That is why this is used. And in epoxy resins, it can be used from small quantity to high quantity, usually whenever there is a large crack or hole, and wherever there has to be some filling to make it look normal. Whenever it has to be a plain surface, we use the epoxy resins to fill the crack or fill the hole and make it completely new. Basically epoxy resins strength is completely depending on the temperature of curing that we do, and the method of application that we follow. There are multiple methods of applications of epoxy resin, and when the epoxy resins can't be used and for the larger void spaces, so we mix this epoxy resins with low viscosity or high viscosity epoxy resins of low viscosity or high viscosities of sand aggregate, and that particular mixture is called epoxy mortar. So, basically epoxy resin is used for smaller cracks or smaller holes. When the cracks are bigger or the holes are bigger, we mix this particular epoxy resin with sand, and then we make that becomes epoxy mortar, and that is what we fill in bigger areas. So, epoxy mortar is better for bigger areas because of the high compressive strength that kind of holds it together and makes sure that it gives it high tensile stress and a less elasticity modulus. Mortar is this particular mortar is not a stiff material for using reinforced in reinforced concrete, and that is when we use gypsum cement mortar. So, gypsum cement mortar has got very limited use for structural application because this particular element has the lowest strength amongst all the other materials that I just discussed with you. Next is a quick setting cement mortar. So, quick setting cement mortar is patented just basically for the steel blast furnaces. So, that is also used for this particular use. Again, mechanical anchors are nothing but basically anchors to provide anchorage on those areas which needs to be given sufficient tensile strength or resistance. So, this kind of gives both shear and tensile strength and make it hold it together, and that is when we use mechanical anchors. So, these are the major repair materials that we use. So, moving on to the summary. In this lecture, we saw the basics of the urban planning and the design from the seismic perspective. The lecture covered the vulnerability of existing buildings and discussed on how to tackle the same. The lecture discusses about the repair, restoration and strengthening processes of the existing buildings and the various materials to do the same. We discussed about the various repair materials of the buildings. So, moving to the questions, elaborate the following terms: urban planning, repair of buildings, restoration of buildings, strengthening of buildings. What are the typical vulnerabilities of existing buildings? Elaborate the concepts of repair, restoration and strengthening of existing buildings. What are the various repair materials? Elaborate. So, in the coming lecture, we would be seeing what happens when a fire strikes, as a fire comes as the aftermath of the earthquake. What are the various socio-economic factors that happens once an earthquake strikes? What are the various problems and aftermaths of the earthquake, and how does an earthquake directly affect the human life in any particular area? Thank you.